So we've got a nice crew on board here today, and the subject of this webinar is FanTestic air leakage measurement software. So we're going to run through a few slides real quick, and the bulk of the presentation is going to be on the actual tools, which are pretty much a matter of playing around with and seeing what the capabilities are. So the first thing I'm going to show you is the virtual gauge, which allows us to duplicate or emulate your gauge on the screen by simply hooking it up with either an Ethernet cable or a USB cable. I don't know why this is advancing itself on its own, but it is. So I'm hooked up by USB right now because I've got multiple gauges hooked up, and we can hook up, I think, as many as 24. I think I was told we can even go above that if you really need to, and put them up on the screen. Let's just drag a virtual gauge onto the screen and so you can see what it looks like. First of all, what I do is I click on the icon on my desktop, and this appears, and this essentially is a virtual gauge. So what I'll do is I'll just close this one down, and I'll bring it up again by clicking on the icon. So let me just drag over here so you can see exactly what I'm doing. So here's for the gauge, and I simply click on the icon, and the gauge appears. So once the gauge appears, we open up the tools on the side there, and we can increase the size of this gauge to whatever size you want. In this case, I'm filling the screen so you get maximum resolution. And in this case, we want to find gauges. We want to run real gauges. You can also do it or run it in the gauge simulation mode where it pretends to be a gauge. So we go find gauges here, goes out, it finds all the gauges that are connected to this network. In this case, it's 3. And so we're going to choose the bottom one, that serial number. So all we do is we click on it, and that gauge appears, and we can close it down. Now, if you had the gauge in your hand, what you would see is exactly on the screen here. Everything that I do on the gauge will appear on the virtual gauge, and everything I do on the virtual gauge will appear on the real gauge. So whenever we're running a test, whether it would be a single fan test or single gauge test or multi-gauge test and so on, the first thing we'll do is typically we'll take the gauge in our hand and we'll run the fan up and down and find out whether it's hooked up properly and so on. Now, since I can't show you the real gauge, I'll show you the virtual gauge. The advantage of the virtual gauge when you're running multiple fans is you can bring them up. Like I have another gauge over here, as you can see, which is a different serial number, and I can operate that gauge with this virtual gauge. I can do exactly the same thing with the gauge in my hand, but since it's harder to show you that, I'm going to show you the virtual gauge. So what I've got hooked up here is I've got 2 fans. The building is a 2-story building, and you'll notice that I've got a 3.9 Pascal pressure that's bouncing around a little bit, which is the pressure between indoors and out without the fans running. So the first thing I would want to do is to take a look at the pressure range that I want to run my test at and make sure that I can actually get the pressures that I want to get. So in this case, we can start out by just turning on the fan. I don't know if you can hear that in the background. So the fan's running. I want to increase the speed a little bit here, so I'm just clicking on plus 5%, so now I'm at 27%, and you can see I'm up to 15 pascals. Just going to run it through its range and make sure everything is okay before I go into any kind of automatic mode. So you might be able to hear that in the background a little bit. So I'm up to 10,000 to 11,000 CFM. So I'm going to stop that. That seemed to work just fine. So got a single fan, and at this point what I'm going to do is I'm going to set the virtual gauge aside, and I'm going to open up FanTestic. Someone asked me what to choose to use the manual gauge on the blower door to get it up to speed. I think you mean there that, can we do the same thing on the gauge? Absolutely. Anything that you see that I'm doing on the screen here, I can do on the actual gauge. So I can go to the gauge, I can run it up and down, I can stay fine. So certainly if you're doing a single gauge test, you would do the same thing. You don't even have to get the gauge to control the fan, and all of our fans have got speed controls on them. You disconnect the speed control cable, which is an Ethernet style cable. Doesn't plug into the Ethernet, but it's an Ethernet style cable. You turn it to 0 to reset itself, then you turn it up, and you can get the fan to operate. So that's the simplest way to do it, and then just look at the gauge and see what readings you get. The next one is you can do what we did and just set speed by percent. I call that kind of like the TV remote. You just kind of jog the volume and jog the speed up and down. Or you can go set pressure. Each one being a little bit more complicated, but certainly you can do any one of those things. The gauge on screen will show you everything that you see on the gauge, and in the case of using a manual speed control, then the knob, you won't see that. What you will see if you use the set speed function, you will see that set speed function on the gauge duplicated on the virtual gauge. So I'm just going to close this down. Now, one little thing to remember is that we can only talk to one device with one program at a time. So if we're going to talk to the gauge with virtual gauge, fine, we can do that. If we want to talk to the gauge with FanTestic Integrity, the software, we can do that. But we can't do both things at the same time. The problem with that is that you've got two masters telling you to do two things, and it doesn't know what to do. So we're going to turn this one off, and we're going to open up our FanTestic software, which you can download from our website. You don't have a copy of it. What will happen when you're online, here we go, is that it will check for updates, or you can push it to check for updates if you want. So this is FanTestic. This is FanTestic in its find the file mode. And you notice this building here, which is the one that I started the test on last night. We actually have a picture of the building, so you can associate a picture of the building with each test, so you can very quickly find out which test you're on. Someone asked, does this software work with the DM2? Yes, it does. The development of the software has been over since the year 2000 was our first automated software that we came out with, which is called, what was it called? Energy 2000, and then it was followed by Dorfan 3.0, and then this is an entirely new software package, FanTestic Integrity, which is a different level of software, and I think we have roughly 5 years in this, and probably I don't know, 3,000, 4,000 hours of programming that's gone into this so far, so it's certainly a major effort. A lot of tests in Europe, when they test to standards, they do not test anything other than automated. So all of the systems that we sell offshore, I won't say all, but in a lot of countries, they refuse to allow a human to operate the controls. They automate the thing from the start to the finish, and that's the reason why this software is as sophisticated as it is. So we're going to bring this software up, and in this case we're going to run a new test, brand new test. Over here we can select an image. I won't bother doing that. in this case, we are going to run a test with a single fan. So I'm just going to go into Tools here, Advanced Options, Settings. Now, I've gone in and I've changed all the settings here so that I can show you a test and not have to wait for 10 minutes while it collects numbers and so on. The idea of this software is basically you set it to the standard you want, you press the go button, it takes all of the readings and shuts itself down and creates a report according to that particular standard. If there are any decisions that have to be made, the software can make them along the way, and if doors are open or whatever, it will actually stop taking data until the door is closed again. You do have the ability to operate it in semi-manual mode, which allows you to change one particular point, automated. But essentially, when the software comes out of the box, if you choose to use, in this case, the ASTM standard, E779-10, it will perform the test according to that standard and follow every single rule in ASTM E779. So if you wanted to do a test of this standard, you could basically take the software, open it up to that standard, press the go button, and it would basically do the test for you. Of course, before you do that, you've got to check to see whether the fan you have is capable of producing the pressures that you want to produce, that things are hooked up right. There's all kinds of little things that can go wrong. So you don't want to put it in automatic mode until you've had a chance to check it out. So what we're doing here is we're just taking a quick look at the settings, and I've dramatically reduced the time that we're going to spend taking baseline readings, which here is called bias readings. So here I said we're going to take 6 bias readings for 10 seconds each. Normally we would take 10 or 12 baseline readings for 10 or even 20 seconds apiece. So with the stabilization between the sets of readings, that might take 10 minutes or so. We don't want to take that much time. Then for the induced pressure readings from, in this case, 75 to 20 pascals, we're going to take them for only 4 seconds each. We would normally take them for 20 seconds minimum, maybe 30 seconds on a windy day. Here I've adjusted the arrival criteria, so the software is smart enough to decide whether it's arrived at the test pressure that you want it to go to, so you don't have to make those decisions. And once it feels that it's at the pressure you want it to be at, it starts taking data. So the arrival criteria can be very wide, which I've made it here so I can fire a lot of readings into it really quickly, or it can be very narrow, so you can say, well, if I want to set the pressure at 50 pascals, let's say, for my first point, I want it to be plus minus 1 pascal from 49 to 51. So very narrow arrival criteria, which would mean that the software would simply take more time to take those readings. The nice thing about automated mode or automatic mode is that you can essentially set the software up to take the readings, in some case many thousands of individual readings according to your criteria, but you don't do anything. All you do is you have a coffee or you have a conversation or whatever, and it does all this automated. And we also have what's called a bias or baseline. I wouldn't use the word bias, that's a European term. Baseline, same thing. Baseline stability required before the testing. So it tells you how much fluctuation in pressure that we will tolerate before we start the test. So if, for example, you are doing one test following another, or you want to end the test and start taking baseline readings, the fans will take a certain amount of time to slow down and stop, and different fans take different amounts of time. Our high power fans, for example, run on variable frequency drives. They stop almost instantly. The residential fans, house testing fans, I call them sometimes, have different kinds of motors, and they will take longer to coast down, maybe 30 seconds or so, maybe even a minute. So this checks to see that the fans have stopped running before you start taking your baseline readings at all. So the cool thing about this is that you can't really do anything wrong. Basically set it up, take some tests, change the numbers around. You can always go here and reset back to standard defaults and see how these parameters affect your results. So we're just going to say OK here. So in this case, I want to do a test with this particular gauge. So I've got another gauge hooked up to this, which is this one, and I'm just going to remove that gauge. It says delete test fan. And so I'm now only doing a test with this fan. Normally, you wouldn't have this decision because you would only have one gauge hooked up. So, and then we would go through and, fill in these various values here: building height, enclosure volume, floor area, enclosure area, and so on. So those would be put in there for getting values like air change rates, airflow per square foot, etc. This software package gives out every conceivable result you would ever want. Some of them you may not need, but it gives them all to you, so you can choose in your report, in the Word report, which ones you want, so it will only bring out the ones that you want. When we run the software, it gives them all to us. In this case, we're running this fan here. As far as changing the fans are concerned, we simply click on the little button there, and it brings up all the different fans that you can use, including fans from other manufacturers are in the choice list, some of our older fans and so on that you can use. We find sometimes it's better to give people a picture of the fan so that there's less chance of making a mistake. And then we can put the serial number of this fan in there, which it will keep. So in this case, we're going to say office building and so on. Pretty straightforward. So this software package is designed so that each section has a little roll-up. So in this case, application information, we'll just roll that one up. Equipment, we've taken care of that, so we'll roll that up. Building details, okay, we're taking care of that, so we'll roll that one up. And now we're into the test part. Okay, so I've got the building deals set up. Temperatures. This is important. It's asking you whether the operator is inside the building or outside the building. The reason why it's asking that question is based on the sign of the pressure that comes back. It will tell us whether we're pressurizing or depressurizing the building. So obviously if we're outside and we're pressurizing, we're blowing air into the building that flows away from us. If we're inside, it's just the reverse. So here we're outside the building. So by outside, they mean the gauges are outside. So we're just taking a look at that icon. So there's the operator standing outside the building with a gauge in his hand. Okay, so we're outside the building. And all we need to do now at this point is to begin auto test. Now, if all goes well, it always takes another look to see if it can find the gauge that you're looking for. So it's now collecting data for the baseline. I'm just going to abort this test for the time being and go back up to, so it's found a whole bunch of gauges here. I want to eliminate those gauges. I think I've actually got a whole bunch of gauges hooked up to this, so I'm not able to trick it to tell it that they're not hooked up, and I don't want to disconnect them. So I think what I'll do is I will jump to a multi-fan test, and basically does the same thing, just runs 2 fans. Otherwise I have to go out and disconnect those gauges and connect them up again. So I'm just going to delete that one and go back to, this is the test that I did last night. So I'm just going to bring this up. Here we go. So I've already completed a test on this, and I'm going to duplicate. This is called a set. So I can do as many sets as I like. So let's just go find gauges and see what gauges it's going to find. Okay, I think I figured out what was going on here. It was actually finding another gauge that someone else was using in our office and doing another test, so it's finding that gauge as well. So that caused a little bit of confusion. This won't normally be a problem for you unless you've got two people doing two tests simultaneously in your building, which will probably never happen. But in our office, we've got people running around testing all over the place. So I'm back to the two gauges that I have on my test setup here. So I'm going to go back to begin auto test. Just going back to our test here, you'll notice that it's taking the baseline here and it's starting to flick the numbers into the software package. I think I'm only taking 6 readings, so it's almost done. Taking baseline, I hope. Okay, so now the fans have started up. You might hear them in the background there. And it's seeking 75 pascals. We want to take a look at what's happening. We can see that this is the pressure that's being achieved over here. So it's taken its first point. It's now going to start searching for its next point, I believe. So now it's seeking 64 pascals. We told the software to do a test from 75 down to 20. You can do it the other way around if you want. If you tell it 20 to 75, it will go the other way. 75 to 20, and it's going to break that up into 6 equal segments. You can hear the fans. I don't know how well you can hear them. I just shut the sound off briefly there. I'm not sure if you can still hear the fans running. But we're now seeking 31 pascals, and probably the next one will be around 20 pascals, and our test will be done. This is a very, very fast test, much faster than we would take normally, but just so we don't sit here, hearing the fans grinding away for a long period of time. So now it's seeking its target pressure of 20, and you can see on the gauge over on the side here that it's dropping close to 20, and this is the total flow that's going through the system. I don't think there's anything more boring than watching software taking data automatically. So the fans have shut themselves off at this point, and it's going back into taking the baseline again. It's reviewing the stability to make sure that it's stable before it completes the final baseline. But you can see here on the software that we've only taken 6 points just to kind of keep it down. So here you'll notice that when we scroll down that this was set number 1 that we just did. And these are all the results that we got, by the way. We've got airflow at 50 pascals. We've got air change rate. We've got flow per unit floor area, flow per unit enclosure area, equivalent leakage area, LBL, effective leakage area, lead permeability, which is effective leakage area per 100 square feet of floor area, I believe. All those results are spewed out, and the confidence interval for each one of them is described, and that consists of a complete set. So we'll take that set and we'll collapse it. So that's set number 1. This is the one we just did. So if we want to do a new set, we're all ready to do a new set. All we have to do is say begin auto test, and a new set will be performed in exactly the same fashion with the same settings that we had before. This is what we call common control. This is what we would do if we had 3 fans that were stacked up on a doorway that were basically pressurizing the same space, say a large warehouse or something. So let's just take a look at the control signal. So here's our main fan here, and it has a control signal coming out of it. And notice where the control signal is going from this fan. It's disconnected. So this control signal from this gauge, which is our master gauge, goes into this fan, and all of our fans are set up so we can daisy chain them together. So we take this control signal, and which is kind of this browny orange, and we run it into the next fan and into the next fan. So all of these fans will run at exactly the same speed. Now, that's not going to work if they're in different locations. So let's look at how that control will look like. So this is common control on our DM32. DM32 in the software, we can actually tell it to have individual control or common control in the software. We don't actually have to make this wiring change. So I'll show you hopefully later where that setting is in the software. It says individual control or common control. So this is common control and this is individual control. So here, this gauge is controlling this fan. This gauge is controlling this fan. This gauge is controlling this fan. Now, if these three fans were all blowing into the same space and one of the fans just happened to slow down a little bit, the other one would pick up the slack and we can actually get one fan stopped and in some cases stopped completely and air coming back through it the other way without even knowing that that's happening. You really have to experience this to believe it. In the case of residential house testing fans, one of the disadvantages of using those for testing large buildings is if you get them spinning backwards fast enough, you can actually get the fan to run backwards. So you might have two fans running forwards and a third fan running backwards. I've seen that many times, and I know in tech support that I've had that situation arise, so it's something to be aware of. So let's see if we can take a look at the settings. See where it says individual control here? So we've actually got this checked for individual control. So each fan would be given its own set point and its own control signal. And this won't make any sense to you at all until you put two fans blowing into the same space on separate control, or I should say individual control, and seeing one fan take over from the other. It's kind of like two people working on the job. The lazy person wind up doing less and less and less, and the other guy's doing all the work. Well, that will happen if you've got two fans blowing into the same space and they're both in individual control. We only use individual control when the fans are blowing into different spaces. This is a bit advanced for certainly single fan testers, but this is something that when you go through our manuals that are probably worth taking a look at right now. Let's just take a look at what we have in the way of manuals. So the first one is the manual on FanTestic for ASTM. So we've actually provided a separate manual. Here it is. This is 24 pages, and it goes through the running of the software and every single thing that you need to know about running a software in color. Basically, if you just ran through this manual from start to finish, it would walk you through every single one of these scenarios. So that's on the software. The next one is large multi-fan testing. We've pulled some of the pictures out of here for the presentation. Here it shows you how to hook the fans up. So here we show the different kind of buildings that you might run across, different kind of tests that you can do, how you're going to set the software, different multiple fan scenarios. Here we go into running two fans in the same zone and what might happen where one fan takes up the load and the other one might stop or run backwards. So all that's handled in really nice detail with super nice graphics. How we would hook up a multiple fan situation with, say, 3 fans in one bank, 3 fans in another. It's all covered very nicely. These are all available on our website. If you can't find them, support at retrotec.com. And for every different kind of equipment, whether you have DM2s or DM32s, you want to mix them up, mix and match, you can do that fine. It shows you exactly how to hook them up. The big difference between the DM2 and the DM32 is the DM32 will run over 330 feet or 100 meters of Ethernet cable. So you can be 330 feet away from the gauge and plug that into your computer and run that gauge just like it's sitting right beside you. The way the DM2 worked is that you actually had to run the tubes over that distance. So in this case, we have 75-foot extensions and so on. Not quite as convenient, but still worked fine. Probably 70% of the large buildings in the world tested were probably tested with DM2s using this exact technique. They've been using these gauges and these fan systems for testing all the large buildings in England now for, I think, 12, 15 years or so, which is where a lot of this technology was developed there, which is developed for that market, I should say, because they were the first country to require that form of testing. The next thing is another manual on residential air leakage test systems. This is also a 73-page manual. Basically goes through everything that you would ever want to know. It's kind of like a training course in itself. Shows you everything to do with residential testing. 73-page manual, no charge. Take it off our website. Manual on the DM32 configurator, which is the way that you can take your DM32, plug it into the internet and update it online. Shows you exactly how to do that, how to change the settings, and so on. Very nice manual there. Another nice manual on the virtual gauge that shows you exactly what the virtual gauge will do, how to set it up. You'll notice this one has the red sides. The first 500 we built were a standard off-the-shelf case until we came out with our yellow custom case, which is kind of smaller and a bit cooler, but they work pretty much the same way. So the screen itself is the same, as you can see. If you are running energy conservatory fans, or you want to put some of your energy conservatory fans into the loop, this is a manual on how to run an energy conservatory fan with our software and our system. We have an adapter that will adapt our gauge to the energy conservatory fans. If you decide you want to use one or more of those, you can mix and match fans in the software. As you can see, if we go back to, equipment, you can choose from a variety of fans here, and you can mix and match, and it handles that just fine. This is a quick guide that we developed for running 3 fans together. This is for the old DM2s, which still a lot of people have. We also have a blower door quick guide that shows you how to do this. If you were to get one of our standard, let's say 1100 blower doors in the package and run through this quick guide, from the time you open the first box, the time you do your first test, no more than half an hour time will elapse. So very easy to run through these steps. Everything's color-coded. Pretty hard to make a mistake. You see pictures of all the different things that you're going to be setting up. And then the quick guide for the DM32 itself, which basically walks you through all the different screens and how to get to here and there. This took a lot longer than I had thought. I'm going to continue online here, and we'll answer any questions and try to run any kind of test I can. Even though I set the parameters for the software about 3 or 4 years ago and have input in it from time to time, I don't actually use it very often myself. I just read it last night for the first time. It's pretty intuitive. If you do run it and you have a problem, we do have support, and we can support you. And I haven't even read the manuals, I have to say, even though I've written portions of them, but haven't sat down and read them. We make changes, probably 50 changes to this a month, little improvements as time goes on. It won't talk to different kinds of computers. It won't do this. It won't do that. It seems like we're dealing with a changing field when it comes to operating systems and so on. So we make a lot of changes that make the software more bulletproof. It's now quite stable, so if it gets interrupted partway through, you can pick up where you left off. Before, you couldn't do that. You'd have to start over again. So we keep building in more and more stability into the software package. I'm sorry I didn't run through a cost of infiltration analysis to make sure that my example made any sense. I did run through it several years ago when I put it together, and worked fine at the time. The cost of infiltration analysis is really only good for a building probably from 5,000 square feet and down that kind of looks and acts like a house, because that's how that software and the purpose for which that software was developed. Uses the infiltration model developed by Lawrence Berkeley Labs that was meant for residential houses. Once we go into larger commercial buildings, the infiltration analysis for residences that we would use doesn't really apply much anymore, mostly because the HVAC system is a bigger determinant on the fresh air load than infiltration is, unless the building is really, really leaky. So the moment we get away from a residential house, the cost of infiltration becomes very difficult and complicated. There are people who do nothing but energy analysis of large high-rise buildings. That's all they do. It might take them a week or more to do a cursory analysis on a large building. So the level of complexity is many orders of magnitude greater than it would be for a house. So this infiltration analysis is meant for a residential house, maybe 3-4 stories max. But the entire zone inside the house most of the time will be connected together. So we don't have a compartmented building like we do in a large building or high-rise building. It looks like we're kind of running out of juice here, so I'm going to sign off for now and look forward to hearing you all next time. So thanks for showing up.